This is a talk about how we created a configuration management database using Perl. Turn it on. Okay. Creating a CMDB is usually not the first thing you do in a project. It's in most times the first or maybe second, third thing you do when operators take the job. So it happens when people need to get lazy to, well, probably can do their jobs because otherwise they have too much to do for too many people. And well, after we did all that, I mentioned something List told about raising booking. Yeah. Finally, from retrospective, I can say Perl saves our ass. Okay. We started with a goal of a full flavored systems management. We want to be able to install without administrator interaction, at least for, well, let's say 90% of the tasks. We want to control sensors and alarming. We want to be sure that what we sold is also installed at the time when it's paid, and it's get deprovisionized when it's not paid anymore. And we want to be able, in emergency cases, to move around components to maybe other virtual machines and so on. And I don't know if anyone know that title. We need an operation handbook. That means for the past 30 years, we must be able to say for any particular day what's going on which machine. Okay. When I entered the project, we had a kind of installation report. It was an XML instruction document defined by the sales department. It has, well, it was 70% done, and then it's stuck because it becomes complicated. It becomes complicated because the document definition has not really relations between the different entities. It was just, yeah, it has to be there somehow. And the document definition misses the technology requirements. So, well, that's because the relations were missing too. So you cannot say component B based on component A because, well, the document does not care. And this appears to be a dead end finally. You cannot work with something which does not provide you the required relations. Okay. Where do we want to go? Well, we had our goals, and so we could go in any direction. But any direction, I cannot go to any direction. I can't go to one direction. So we have to concentrate on somehow. And management is often not able to throw things away. So we first tried to recover the state we had. But there was no abstraction layer. And because of the missing relations, there was no real chance to reverse the report. So you can generate a report, but you can't read it and install from it. So, no. Okay. So we needed to know what we know and what we don't know. And we discovered, well, not only the documentation and the installation reports and so on is unstructured, the complete platform has no real red line. Okay. We had the installation report, we had some snapshots of the configuration files, we had some Puppet classes that were Python or Ruby code, I don't know what Puppet is written in, mixed with some configuration items in Hira and some prepared configuration files by the operators, completely unsupervised. Hira, for those who ask, is a Puppet built-in key-value data lookup system. So it's a little bit better to have it in a separate data store than in a Ruby hash. A little bit. But it does not lead you to anywhere. Okay, so after we recognized all that, I got the management to paint some circles. We started at the platform. Well, we want to be able to install and read from it, so well, this is our begin and the end. From the platform, we collect snapshots. From the snapshots, we scan our data, make it somehow structured. The scan will be entered in the CMDB. The CMDB will be used to generate Hira key values, and this will be put through Puppet 1 onto the platform again, and then you have at any time the opportunity to say what's going on. And you can compare it. You can simply run the circle again, and when it's all the same, then you are fine. When not, start debugging. We can apply change requests, and we can generate reports, reliable reports. Okay, what do we need technically to reach that? We need to know all the platform parameters, structured. We need to know how the occurrences between those platform parameters and group of platform parameters, which are finally configuration items. We need to define, when we know that, a data model and the technical requirements. That sounds not that complicated, but we need to ensure what is valid and what not. We need to define what are the limits. What can we know, what can't we know? We have to define that, to communicate it to sales, to customer service. We have to declare who is the owner of which item, how we store it, and who is allowed to store and to read it, and how we manage that. Okay, then let's try it. Okay, yeah. It's a little bit much, and we stepped a bit back, thought about it, and then tried some tools to give us the opportunity to get that stuff structured right. MongoDB sounds promising, but we could not get it out in another way than we put it in. Okay, storing it somehow structured into a data file would allow us to read it using dbd CSV, for example, but then we have to complete the business logic in writing the CSV. That's also very difficult. Any data allowed us, finally, to define some coherences and relationship, but express the business logic in SQL. So this was our goal for the tool. But any data does not persist. So we persist the volatile structure from any data in SQLite. Define then a data model for the relations. Develop some format classes representing all the entities and the relationships. Develop a very, very, very simple meta-object protocol to allow us to distinguish between columns, relations, and glue. Put it behind a DBD any data handle and use SQL to copy from volatile scanning to persistent SQLite. But during scanning, well, it remains a moving target for a long time. Yeah. We developed then an abstraction layer based on that. We focused our goal, scan, and so on, and did every component complete scanned before we go to the next component. We identify the relationships between the global components and cleaned up the mess happened over the last, let's say, decade. And detected, don't know, was anyone on the 2015 Netherlands Perl workshop? No? Okay. Then maybe ask Leo, ask Theo for the videos. We had a Mu in practice. We had Mu X CMD to separate our concerns, scan, both scan, persist, and so on. Config from file to allow us to contribute operators' wisdom and not, well, developers were gone. Also, we had the options to override those wisdom by, well, I know it better now. And yeah, we also need the logging, a configurable logging. Because you need to know during developing what goes wrong, and you are not allowed to have customer data in log files in production. We are using Mu to manage our database connections, manage our CI structures and relations, and finally REST API integration. Okay, that sounds crazy. But it's getting better. Over that time, we had a lot of administrators had a different perspective on the entire platform, so we had to harmonize all those craziness. Yeah, there were epic battles in the office. But finally, each battle uncovered more holes and finally let us find a solution. And then another player entered the game. CentOS 5 and its maintenance. We need to upgrade Puppet, new hierarchy structure, and so on. All the old hacks can't be supported anymore. We have to develop a reasonable configuration structure, and we could not stay at the old format because, well, it was full of hacks and what Okay. But the developers who have to develop the CentOS upgrade did not know anything about this platform, and they don't care. So this time we made it better. We did not take the responsibility for filling somehow weird Puppet templates. We did not manage any configuration data. We are not responsible for that. We are providing the operation, not the configuration of components. We do not puzzle any prepared XML stuff together. We give an entity relationship model data, a RESTful API to request it, and the development team has to deal with that. This was another epic battle, but finally it went fine. At the same time we finished that battle, we finished the complete scan. So we had a structured snapshot we can configure, which has a reasonable state, but only this time, no future, no past. So enter the configuration management database, because this tells us about the past and the future, and the wishes and what's also on. So let's have a look. It's a very simplified model for how a customer could look like. Every table has a global identifier, has a payload, and always the same columns to let the CMDB manage the history and the future and responsibilities. Same for relationship example for VPN stuff. We have the identifier, the relationship, several VPN devices to support, and unique networks connected via VPN. And then we had to integrate that. Okay, the database is configurable, we had config from file, and we had a role which allows us to have a CMDB in our components later. And this coerces the configuration hash, creating a CMDB instance. Yeah. And this CMDB instance on deploy creates from the tables with the customer T, VPN T, and so on, the history tables by deriving all columns, add an old underscore and a new underscore for each column, and create it, put it in history table. And when anyone inserts data into a configuration table, create an insert trigger, which copies all the new inserted data into the new prefixed columns of the history table. Same thing for update, but it's a little bit more complicated. We have then the update, the old column, the new column, and we have to compare, because you can update a line without change anything. This happens by rescanning, and you don't know about future and past, so the scanner will put it in CMDB, does not care. This is the touch, yeah. And then create the update trigger, insert or replace. If it's not exists, insert. If it's not exists, replace when it exists. And when we find an already inserted row, which is completely identical to the one which exists, it just touches. Which leads us to how we manage data in the CMDB. There's an SQL feature since 2003, and it's not supported by SQLite. The asking on Stack Overflow leads you to insert or replace, but insert or replace deletes before insert, and that makes your history table explode, because every replace create a new entry in the history table which deletes the line, and another one inserts the same line again. And this happens several times a day. That is not a good idea at all. And then we developed our own upsert feature. This is how it looks like. This is sample generated code without customer data. Yeah, they are secret. And inserting that will create an inserter ignore statement with a customer ID, selecting it from the customer table. Same for update. This is what upsert can extract from the data model. But it's restricted to our CMDB. It refuses updates of identifying columns. Yeah, well, it has to be built a where class somehow. And the where clauses are derived from the unique constraints. Yeah. With that CMDB, we are able to write a YAML generator. It reads the RESTful API, create the YAML files in the way Puppet needed for the different services we provide, create XML snippets, templates, and so on, and rewrite, I would say, 80% of the Puppet code to understand how the stuff belongs together. And then we had a closed circle. We had developed this, and that. In not yet a year. So we reached the goal. We are able to compare if the theoretical state of the paying configuration is equal to the actual state. We are mostly able to do unbanked installation for 80% of the stuff. We can react incredibly fast compared to our previous times when moving stuff, when errors happen. But we did not manage to manage the sensor and monitoring. That's another stuff. Okay. So, we detected, yes, it can save our assets. Any questions? I did not expect it. It's a very, very compact, abstract stuff. Okay, then, thank you.